Well, welcome back to the continuation of the discussion of fundamentals. All of these fundamentals are going to be important for when we move into capturing for HDR photography. We've already talked about dynamic range, the limitations of our camera, the difference between what the human vision is able to perceive in a scene versus what the camera is able to record. What we also want to do is to talk about the image qualities that we will ultimately wind up working with when it comes time to do our tone mapping. And in this particular topic, we want to talk about Jpeg versus RAW. Now, Jpeg is a compression methodology or algorithm that is intended to reduce the file size of an image so that its file size it can be maintained or reduced. Jpeg really is very handy when it comes to reducing an image size for purposes of portability and passing it to other entities, say online. However, Jpeg does a lot of damage to an image. As you'll notice here, we have attributes such as dithered images or edges, or edges that have been softened. There's not a clear distinction between one edge and another, and that's called a dithered edge. Dithered edge obviously does a lot of damage to the image, especially if it has a lot of straight lines. You'll see softened darks, you'll see altered highlights. There's a lot of damage actually that's done to an image by compressing it with a Jpeg algorithm. Probably more importantly is that we have detail loss. Now I know that in these relatively small slide images, it's kind of difficult to really see clearly the amount of damage that's being done to an image. Basically, we want to avoid trying to process an HDR capture sequence using Jpeg compressed images, because basically your camera is doing quite a bit of damage to the actual image. What we really want to try to do is to retain from the camera your RAW. Now, RAW is simply means that the camera does not do any or minimal processing of the image. So what you get as an output from the camera in RAW format is you get a very, very close representation of what the sensor actually detected in terms of light levels. And the file sizes are obviously much bigger than Jpeg, but the idea is that we've retained as much of the detail in the image as possible. And that is actually going to be quite important when it comes time to actually process the images. In other words, you want the maximum amount of detail and clarity that you can get so that you have the best possible opportunities for a really good processed image. So we want to come home with our captured sequence with RAW images, and we want to avoid Jpeg. Really, RAW is going to give us quite a bit of advantages. We have a much better preservation of detail. We have tones that are much more accurate. We have sharpness has been retained. Basically, the camera has not attempted to modify the image in any way. There is some, depending upon manufacturer and camera design, there is some internal to the camera processing of the image. And we really can't control that, but it's typically very minimal. In other words, we want to come home and move into our tone processing, our tone mapping, and have the greatest possible detail and data that we can. And so we want to avoid JPEG. And that's the purpose of this particular topic. And really, it comes down to this, that once you JPEG convert an image, you can't go back. The loss of the data is there and is permanent in the file. So just keep this in mind. We really want to work with RAW. In other words, the camera doesn't perform any or very minimal internal to the camera image processing. Now, there's a lot of advantages to RAW, and you can see this list quite a bit here. You can go ahead and review that pretty much on your own, but let me just summarize. Basically, we minimize quality loss, and we have a better dynamic range. All right, if you recall on the previous slide, I was indicating things like dithered images and loss of tonal quality and the highlights and so on and so forth. Well, that is actually a reduction of dynamic range. We go through all of this effort to take a series of captures so that we have the best possible dynamic range, and then of course much of that is undone by allowing the camera to convert to JPEG. Well, there's disadvantages too to RAW. The file sizes are larger. It consumes more memory on the camera's memory card as well as on your computer. That's basically a price that we need to pay because we're telling the camera don't do any processing and certainly don't try to compress the image. We're not looking for portability when it comes to HDR photography. We don't want the output of our images to be portable and easy to upload and download. We're looking for the best possible quality. It takes longer, obviously, to write the JPEG to the camera's memory card. We're not so much concerned about HDR photography really doesn't serve you well in, say, a sports situation. And so we're really not looking for a very high frame rate. We're looking more for quality. And you know, and there's some other advantages and disadvantages to consider. But let me leave it like this, that whenever possible, you want to have your captured sequence of images outputted from the camera as RAW, unprocessed, so that you have the best possible chances of having a tone mapping experience that will give you the best result. And what we're looking to do is to retain image quality and retain image detail. And so we don't want that all compressed out and damaged by the JPEG. So even though there are disadvantages with RAW, they're actually quite minimal when you consider the disadvantages of JPEG. All right. So let's talk a little bit about bit depth. And well, you know, I've been referring to this 8-bit this 8-bit file numeric file structure for a number of occasions here, but I really want this particular topic to help you understand that when an image is placed into an 8-bit 0 to 128 format, there's a limit to the amount of tones that can be represented in a numeric format. And really it comes down to a pixel tone needs to be represented somewhere within between 0 and 128. And obviously there is a limitation to what that numeric value can be. So therefore there's a limitation to the amount of tone or colors or light intensities that can be represented by that value. Over on the left is a picture, and it's I deliberately chose it because it has a very high contrast between darks and lights. It has a lot of colors, and those colors are tones. And of course you have the intensity of the light that is also encapsulated in the numeric representation of the pixel. And so this little spot right here is being blown up into this, all right? And it's trying to illustrate here that 8-bit tonal representation has certain limitations. And the limitation is that it is unable to capture or to convert a pixel into a much broader range of tonal values. Now, if we're dealing with something like a 16-bit, well, obviously we're going to get more tonal values. If we're dealing with 258 bits, you know, we're going to have a limit in the amount of tones that can be represented. Now, here's the key point that I'm trying to make here. When we have a 32-bit representation of our tonal values, we obviously have a much broader, greater range in which we can digitize those tonal values. Now, here's the key point in all this. Your 32-bit file structure is what you're going to derive once you have processed your captured sequence into an HDR format. You're going to have 32-bit representation of each of the tones. So I think you can already glean from that there's going to be a better representation of the tones within your image compared to 8-bit. Now, I think that the point of this particular topic is to help you appreciate that 32-bit tonal representation of your image pixels is certainly going to be far better than your 8-bit tonal representation of your image pixels. Now, the key thing to remember here is that when you are working with your camera, you're working in 8-bit. When you are processing for HDR, you've actually taken your series of captured images, each 8 bits, and they have been merged together and they have been formed into a 32-bit image file structure. Now that basically means that your HDR processed image is going to give you a much greater range of tonal values. We're going to talk about that some more. This particular topic will be quite important to understand as we move into tone mapping, because it's in tone mapping that we're able to start working with a 32-bit image structure versus an 8-bit, which you're typically going to be working with at your camera level. So the kind of in preparation for our discussion of capture, which is next. It's what you've been waiting for, but we're coming up on that pretty quick. We'll consider here for a few minutes that your 8-bit scene, I'm sorry, your scene, which is recorded in 8 bits, is then going to be converted to a 32-bit utilizing the multiple image capture. Now this happens to be a 3-frame capture for purposes of HDR photography. It could be 5, could be 7, could be 9. We'll get into that particular subject. But now you notice here that with the 32-bit file structure, now keep in mind that we started with an 8-bit, all right, and we have 3 8-bit images, and then that is converted to a 32-bit, which is giving us a much greater range of tonal values. Now we're able to start doing some really cool things with our tone mapping or our processing of that particular image. This one up here, this is using Photomatics. We're going to be using Photomatics when we get to the tone mapping segment, and that's the default preset, and it's giving us a representation of our scene. All right, that's our representation of our scene. The difference is that we were working in 8-bit, now we're working in 32-bit, so basically we can do more with our image. We have a greater latitude to work with during the tone mapping period. And this next one right here is a different preset. This lower one here is a grunge preset. In other words, very, very heavy on detail, very heavy saturation of the tones. And the point of all of this is that HDR allows us to be able to extend our images so that we're able to work with a greater range of tonal values, allowing us to either be creative or we can go for realistic representation of the scene. But it really then it gives us the opportunity to start asking the question, is this a style or is this a process? Is HDR a styling of our images or is it a process? Well, the key point here is that it can be either, because you are afforded the greater latitude in the amount of tones that can be represented for each pixel, 4.3 billion, as we had pointed out in the previous slide. It gives you the ability to stylize your images if you so choose. Looking at another example, so here is your 8-bit image, and here is, in this particular case, 3 8-bit images that have been merged into a 32-bit image and giving us a much broader range. We can do a painterly preset, or we can do a grunge reset. We have much more latitude to work with, and that's the key point. So you've made it through fundamentals. The next segment, we're going to actually be doing field capture, where we're going to take a series of images and then in preparation for actual tone mapping. So I think you're going to find the next segment interesting, and I think you're really going to enjoy the process of capturing for HDR, and then being able to take your captured sequence back to your computer, process them, and be able to derive some really remarkable images. So I hope that the fundamentals has really helped you understand the limitations of your camera in terms of what it can and cannot do in comparison to your human vision. I hope it's helped you understand the dynamic range limitations of your camera. I hope you understand better now that there's certain file structures that you want to stay away from when you're working with HDR. You really don't want Jpeg. You don't want to bring JPEGs back for tone mapping. You will be disappointed. And I hope you also understand that converting, or I should say merging multiple 8-bit images into a 32-bit will give you much greater latitude when you're actually working with your images during the tone mapping, the processing period, allowing you to be able to affect image processing so that you can be creative, you can go for realism, you can bring up the detail, suppress the detail, you can control the tones, control color. There's much you can do in during the tone mapping segment of your work. The important thing to understand is that when you're in the field and you're doing a capture sequence, the success that you have during the processing or the tone mapping portion of your work will have much to do with your actual capture quality. So this is why we want to understand the histogram better, understand the limitations of the camera better, understand certain things that we want to avoid, such as JPEG, so that the idea is that you take the best or the optimum, which is one of the objectives of this particular course. You want an optimum field capture so that you can have the best possible results during tone mapping. So I know this has been a lot to take in. I'm so happy that you're sticking with me on this. We've covered an awful lot of territory. We've got some more work to do yet, but now we're going to move into actual field capture for purposes of HDR processing. And here I think is going to be a critical turning point for you to take much of this information and digest it and actually put it into practice for tone mapping based upon some really excellent optimum field captures. So please join me for the next segment where we're going to be talking about field capture for HDR photography. I'll see you there.